This problem, kind of the same idea. I have fractions as terms, and then I have just a constant value. My fractions have denominators of z minus 1. That's the denominator in both of them. It's more than one term, so that's my entire denominator. That's going to be my common multiple that I'll use to clear it. So I'm going to multiply everything by z minus 1, every term, including the 2. So this gives me z minus 1 times the fraction z over z minus 1 equals z minus 1 times the fraction 1 over z minus 1 plus z minus 1 times 2. This time I have z minus 1 divided by z minus 1. Even though there's more than one term, it's still just something divided by itself, which is equal to 1. Those cancel out, and I'm left with z. Equals z minus 1 divided by z minus 1 is just 1. Those cancel. I bring down the numerator, which is just 1. Plus, I need to distribute the 2. Even though it's on the right side of those parentheses, it's still a distribution problem. So if I distribute that 2, that gives me 2z minus 2. Do a little bit of rearranging. I can subtract 2z from both sides. So that gives me negative 1z equals, my 2z's cancel. I could combine these like terms of 1 minus 2, which gives me negative 1. Divide both sides by negative 1. Negative divided by negative is a positive, and I get z equals 1. Again, be very, very careful because your original problem contained fractions with the variable in the denominator. Your job is to make sure that the solution you get, in this case 1, if I plug that value in for the variable, it cannot make the denominator equal to 0. If it does, I have to throw it out. Well, in this case, if I look at the very first fraction is z over z minus 1. I'm claiming that z is equal to positive 1. Plugging a positive 1 in for all the z's gives me 1 over 1 minus 1, which is 1 over 0. You absolutely, positively, under no circumstances can have that. Any value that puts a 0 in the denominator of a fraction anywhere in your problem has to be thrown out. So we have to toss out the value of 1, which means we have no solution. Always be aware of that whatever value you get, you cannot have it put a 0 in the denominator. Okay, in this case, again, I'm looking at the number of fraction bars, which tells me the number of terms. Oops. So, and then I have that 3 there. So in this case, I have 4 terms. 3, 5, and 4. My common multiple with 3, 5, and 4, let's see, 20, I guess that's 60. So everything gets multiplied by 60. So that is 60 over y minus 3 plus 60 over y minus 10 divided by 5 equals 60 times 2y minus 2 over 4, and I'm out of room, so I'll bring it down here, minus 60 times 3. Please note that there are no fractions that have variables in the denominator, so there's no way that I'm going to end up with a 0 in the denominator, so I don't have to worry about that in this case, which is good. I do, though, still have to worry about clearing out these fractions. 60 divided by 3 is 20, so that leaves me 20 times my untouched numerator, which is y, plus 60 divided by 5 is 12. So 12 times my entire untouched numerator, which is y minus 10, equals 60 divided by 4 is 15. So I have 15 times that quantity 2y minus 2 minus the 60 times 3. If I multiply these out, 20 times y just gives me 20y plus distribute the 12, I get 12y minus 120 equals distribute the 15, 30y minus 30 minus 60 times 3 is 180. Simplify, 20y plus 12y is 32y minus 120 equals, let's see, minus 30 and minus 180. I still have that 30y. Gives me minus 210. If I subtract the 30y from both sides, that gives me 2y minus 120 equals negative 210. Add my 120 to both sides. I get 2y, my 120s cancel, equals, let's see, negative 210 plus 120 is equal to negative 90. Divide both sides by 2. My 2's cancel, and I get y is negative 45. Same thing here. I have fractions, and I have a 1. The fractions both have denominators of x minus 2, so that's my common denominator. So I can take x minus 2 times 1 minus x minus 2 times x minus 3 over x minus 2 equals x minus 2 times 2x minus 3 over x minus 2. Anything times 1 is just itself, so this first one is just going to be x minus 2. X minus 2 divided by x minus 2 just cancel each other out. What I have to be careful about here is that subtraction sign. I'm going to be subtracting the numerator, which I didn't touch, because there's more than one term. I'll keep it in parentheses. Equals, my x minus 2's cancel, so I get that 2x minus 3. If I distribute that minus sign then, I get x minus 2 minus x plus 3. I distributed the minus sign into the parentheses, or negative 1 into the parentheses. Equals 2x minus 3. X minus x cancels each other out. Minus 2 plus 3 is positive 1. Equals 2x minus 3. Add my 3 to both sides, and I get 4 equals 2x. 3's cancel. Divide both sides by 2, and this time I get that 2 equals x. If you notice though, if I go back to the original problem, plugging in a 2 for x gives me 2 minus 2, which is 0, in both denominators. Just 1 would be enough to throw it out. Can't have 0 in the denominator, so this is no solution. If I look at this problem, it might be a little bit difficult to decide what your common multiple is or your common denominator. It's not so bad though if you notice that you can actually factor out a number from this denominator. So I'll do that. I'll leave this one as 6 over y plus 4. There's nothing I can do to factor that y plus 4. Plus 1 equals 5. Now in that denominator I can rewrite that using the distributive property. I'm going to pull out that 2. So that gives me 2 times the quantity y plus 4. If you notice, I just rewrote this going the opposite way from the distributive property. Instead of distributing the 2 into the parentheses, I pulled a 2, which is a common factor of 2 and 8. I pulled that out of the parentheses. Now it's a little bit easier to see that my common denominator needs one copy of this y plus 4, and it also needs a copy of 2. So my common denominator for all of these fractions plus this term 1 is going to be 2 times the quantity y plus 4. So everything gets multiplied by 2 times the quantity y plus 4. So I'll do that to this, plus 2 times y plus 4 times the 1. equals 2 times y plus 4 times 5 over 2 times y plus 4. Again, if you have a little bit of trouble with that, think about what will make the fractions cancel. That's your ultimate goal for this. In this first fraction, 2 times y plus 4 divided by y plus 4, my y plus 4's cancel, so all I'm left with is that 2 times the numerator that I didn't touch, which is 6. So just like that, this big ugly thing went to 2 times 6. Plus, in this case, I was just taking the 2 times y plus 4 times 1. Well, anything times 1 is just itself, so that gives me 2 times the y plus 4 equals, in this last one, I have 2 times y plus 4 divided by 2 times y plus 4. The whole things cancel out, and that whole big ugly mess just goes to 5. Pretty simple from here. 2 times 6 is 12, plus, if I distribute that 2 back in, 2y plus 8 equals 5. My like terms, 12 plus 8 is 20, plus 2y equals 5, minus the 20 from both sides. I get 2y equals negative 15. Divide both sides by 2, and I get y equals negative 15 halves. If we check that, we can see that that is not going to put a 0 in the denominator of these fractions, so negative 15 halves is my solution. In these problems, we are solving a formula for a specific variable. In this case, we're solving for d. Well, if you notice, d is being multiplied by something, and then that whole term, this is one big term, is being added to a different term, the a sub 1. Please note that when you have different subscripts, like in this case we have an a sub n and an a sub 1, those are two completely different variables. The subscripts, the different subscripts make them different variables. Well, we want to get that term that has the d, in other words, this whole big mess, all by itself on one side of the equal sign. So I can do that by subtracting the a sub 1 from both sides. We just talked about how the a sub n and the a sub 1 are not like terms, so I will just leave that as a sub n minus a sub 1 equals, the a sub 1's cancel, and I get n minus 1 times d. Well, now the only reason that the d isn't by itself is because we're multiplying it by n minus 1. So I will divide both sides by n minus 1. My n minus 1's cancel, so this leaves me with a sub n minus a sub 1 divided by n minus 1 equals d. We solved for d because we got it completely by itself.